Water is well wet, right? So how is that with the addition of a small amount of a chemical, it can become a semi-solid, a gelatinous lump that makes for a great food. The reason for this is gelatin, a curious chemical that seems to defy physics and turns liquids into solids. Let's take a look at the chemistry of how you will make Jell-O.
Most of us know gelatin from the dessert Jell-O. This popular treat has been around since the 1890s, and the main ingredient is gelatin, a complex chemical that has some interesting chemical properties. At room temperature, it is a solid. Heat it up to body temperature and it becomes a liquid. So when you eat it, it literally melts in the mouth. Gelatin itself has no taste. The flavor of Jell-O and other similar desserts comes from the added flavorings. Gelatin, however, is responsible for the release of these flavors as it melts and releases the liquid that is holding onto, which contains the flavoring.
Gelatin is made from long strings of amino acids, the fundamental building blocks of proteins. With a bit of hydrogen attached, these long strings, each usually a few hundred amino acid blocks long, are generally fond of each other. At room temperature, they stick together in a formation called a triple matrix. This allows each chain to bond to several others and form to a complex 3D matrix. When you heat the gelatin up, these bonds between the chains loosen, turning the chemical into a liquid as they slide away from each other. But each other isn't the only thing that these gelatin strings like to stick to. They also have an affinity for water.
These gelatin chains have hydrogen atoms attached to their sides. These hydrogen branches can weakly bond with water. This isn't a true chemical bond. The water remains as good as old H2O, but the oxygen atom is weakly bonded to the hydrogen atoms on the sticky out branches of the chain. Chemists call this a hydrogen bond. If you give the water a bit more energy, such as heating it up, this hydrogen bond will break, and the water molecule will drift away. As the water cools, it slows down until this weak bond can be re-established, linking the water to the gelatin chain again.
In a cup of warm water, all of the water molecules are happily bouncing around, and in some gelatin, and the gelatin will dissolve in the water, while the water molecules stay in motion, but as the water cools, the molecules slow down and start to bond weakly to the hydrogen on the gelatin chains. On each chain, there can be hundreds of these oxygen branches sticking out, each of which could bond with a water molecule.
As the mix cools, these gelatin chains also connect to each other in a curious triple matrix structure. Eventually, these interlinked chains of gelatin form a huge 3D maze, with most of the water stuck to it. That's the gel form of gelatin and water, a complex matrix of loosely bonded water and gelatin strings, all stuck together to form a semi-solid. This is why a relatively small amount of gelatin can produce a lot of gel. This is because this 3D matrix can hold a lot of water and still be fairly strong, because the long chains can still connect when they are holding on to many more water molecules. There will be small amounts of unattached liquid water in between the chains, but not enough to create a liquid.
If you heat the gel by putting it in the microwave or into your mouth, the water molecules get excited and the weak bond is broken. The water molecules float away and you get liquid water. The same happens with the bonds between the gelatin chains, breaking down the 3D matrix to form a liquid. So, the gel melts in your mouth.
Gelatin is created by the breakdown of collagen, a protein used by all plants and animals to bind cells together. About 30% of your body weight is formed by the collagen in the extracellular matrix that holds your cell together. Collagen is a very long chain of amino acids that bonds to itself in a triple helix structure, creating a flexible link that allows cells to move a little, but still maintains the strength of the overall tissue. It isn't very easily soluble in water, so fluids can move around between the cells, carrying the nutrients that the cells need to live.
You go from collagen to gelatin by, to put in bluntly, boiling down the bits of animals that people don't eat. When you boil down tissue and bones, this collagen breaks down into gelatin, which has shorter chains and more hydrogen poking out from the chain. After much boiling and filtration, this gelatin can be extracted.
So this is the process behind gelatin.